Okay, gang, we're going to take another stab at Unit 11, Day 3, getting all those answers to you. If this doesn't work, I can take pictures of them, but let's go through these relatively quick here. What I'm going to do is I'm going to solve one of these things for one variable. I'm going to write y plus 1 equals x. And then in my other equation, I'm going to write y squared equals negative 4 instead of x. I'm going to write in that y plus 1 business. I get y squared. Over here was a minus 4y, so on this side would be a plus 4y. Over here would be a negative 4. So over here, I'm going to get a plus 4 equals 0. I think that this is y plus 2 quantity squared equals 0. So apparently y equals negative 2. Now that I know what y equals, I can plug back in and figure out what x equals. So if I have a negative 2 equals x minus 1, I'd add 1 to both sides, and I would get a negative 1. X equals negative 1. Looks like a good answer. I'm going to write it as an ordered pair, negative 1 comma negative 2. And as recommended, I'm going to try both of these. Negative 1 equals, negative 2 equals negative 1 minus 1. Yes. And negative 2 squared, so 4 equals negative 4 times negative 1. Also, yes. Okay, and that looks pretty big and legible on my screen. Hopefully, same for you guys. Over this time, I am going to solve for y again. This time I'm going to get that y equals 8 minus x. So I'm going to say 8 minus x, which is y, equals x squared minus 12x plus 36. Put that onto my screen a little bit better. I am going to add x to both sides. I'll end up with a minus 11x. I'll subtract 8. I'll end up with a plus 28. And I still have an x squared over here equals 0. This factors as x minus 7 and x minus 4 equals 0. X equals 7. Okay, if x equals 7, I can plug back in. 8 minus 7 is 1. So I get 7 comma 1 as one of my points. 7 comma 1 or 4. And again, if that's 4, 8 minus 4 is 4. So I get the point 4 comma 4. I believe the last time through we plugged these both in and they both worked. Let's give it a shot here. 1 minus 12 plus 36 is 7. That would be, holy cow. I don't think that one does. Oh, sorry, other way around. 7 squared, so we're at 49. Yikes. So 49 minus 12 times 7, so minus 84. So I think we're at what? 35 there, negative 35. Negative 35 plus 36 does equal 1. Yes. 4 squared, 16 minus 48. So that should be minus 32 plus 36 does equal 4. Yes. Okay, those are my answers. Looks nice and big on the screen. Moving on. This time, let's use elimination. I'm going to subtract these two equations to make life a little bit easier. I'm going to subtract the top one from the bottom one. Hit the focus button and see if I can make that a little bit more clear. Like that. Does that look better? Okay. So I'm going to get y squared minus y, and 25 minus 19 is 6. That is y squared minus y minus 6 equals 0. Y minus 3 and y plus 2 equals 0. Scoot it up a little bit. Y equals 3 or negative 2. If y equals 3, looking at my 3, 4, 5 triangle, x equals 4. So I have the point 4 comma 3. 4 comma plus or minus 3, I should say. Ooh, Interesting. And in -2, well, that's not a 3, 4, 5 triangle, but plugging in -2 squared is 4. Subtract, I get 21. Take the square roots, and I get that x equals plus or minus square root 21. So plus or minus root 21, comma, and -2. Plugging both of those in either case, I'm squaring this first, so the plus and minus don't matter. And it looks pretty good. Nice and big on the screen, hopefully nice and clear. Let's continue on. Here, I could do some substitution. Let's do substitution, but what I'm going to do is I'm going to say that x squared equals y plus 9. So I'm going to rewrite that top equation, and every time I see x squared, I'm going to replace it with y plus 9. So I've got y plus 9 plus another y squared equals 1, better known as y squared plus y plus 8 equals 0. How about a no solution, because b squared minus 4ac is less than 0. b is 1, and 4a and c are all at least 1. So no solution on this one. No solution. Okay. Continuing on. Ooh, I got a bear. Hang on, let me pause this and talk. All right. Oh. Okay, Harper's taking a nap. Got it. Okay, so over here, what I'm going to do is I'm going to solve for x in terms of y, or y in terms of x. I'm going to write this as the natural log of x equals the natural log of y cubed, and then eliminate the logs. X equals y cubed. Do a little substitution now. I get y cubed equals 9y. Write it as y cubed minus 9y equals 0. Y times the quantity y squared minus 9 equals 0. Y equals 0. This factors, but hopefully we see plus or minus 3. Now, looking at my original equations, the natural log of 0 doesn't exist. The natural log of -3 doesn't exist. Y has to equal 3. If that's the case, 9 times 3 equals 27, and that is my point, 27, 3. Scoot it over a little bit. All looks good. Okay. Not too many more of these guys. Again, I am going to solve one of them. Let's say that y equals 6 over x. Let's write this as x plus 6 over x equals -5. Let's multiply everything by x. I'll get x squared plus 6 equals -5x. How about x squared plus 5x plus 6 equals 0? And x plus 3 and an x plus 2 should do the trick. X equals -3 or -2. Y, the corresponding y values are a -2 or a -3. So some nice symmetry there. And a bit higher. Okay. There is my work. There are those solutions. Hopefully that's all good. We got two more. Let's get her done. All right, technically this is the transitive property. Y equals this, y equals that. Well, this equals that. And I get that x squared minus 5x plus 8 is equal to -x squared minus 5x plus 10. Get that in there. I get a 2x squared when I add x squared to both sides. When I add 5x to both sides, the 5x's go away. And when I subtract 10, I get a -2. This side now equals 0. Let's divide everything by 2. x squared minus 1 equals 0, x equals plus or minus 1. Let's plug in to find the corresponding y value. So 1 minus 5 plus 8, that is 1 plus 3, I get a 1 comma 4. Negative 1, this would still be 1, that would now be plus 5, so I'm at 6, plus 8, I get a negative 1 comma positive 14. And I think it works out just the same for the other one as well. Nice and big, nice and clear, we like it a lot. Last one is reminiscent of a test problem. Let me zoom in a little bit here. I'm going to get that 3 to the x equals 3 to the 2x minus 2. If I say that a equals 3 to the x, I can write this as a squared minus a minus 2 equals 0. That is a minus 2, a plus 1 equals 0. That is a equals 2 or negative 1. That is 3 to the x equals 2. Can't see what I'm doing. Or 3 to the x equals negative 1. Not a thing. So here we go. Let's take the log base 3 of both sides. And I get that x equals the log base 3 of 2 as a final answer, which is fine in terms of an answer. It is not in calculator ready form. We could write it as the natural log of 2 over the natural log of 3 if we were so inclined. Okay, hopefully that helps. I will see you guys next week.